Well, hello friends. Welcome to the SerenityOS update for January 2023. It's been a productive month in the project, although I myself was gone for about 75% of the month in illness, but all the other people worked really hard on a lot of really cool stuff. And I think we had almost 1,300 commits in the Serenity repo, so there's a lot of awesome stuff to look at. And we are going to do that right now. Okay, here we are on the January edition of the SerenityOS desktop. And the first thing you will notice, of course, is that we are in higher resolution than usual. Normally, we've been doing these update videos in 720p. Today, we're switching to 1080p and trying out the system with vector fonts instead of our usual bitmap fonts. So, this is something I've been working on this month, improving support for vector fonts throughout the system. And there's still a whole bunch of stuff to do, but it's already pretty okay. We have various little alignment issues here and there, and just general rendering fidelity can always improve. But the type of stuff that I've been fixing is like, menu bars now respect the font size instead of being hard-coded, or window title bars or like buttons, stuff like that, actually care what the font size is instead of just being hard-coded to like 19 pixels, 15 pixels, and so on. And there's a billion metrics in the system that we need to make honor font size, but yeah, it's already usable, as you can see, at least at some font sizes. So we are trying that out today. And speaking of fonts, by the way, let me show you something cool. So Benjamin has been working on a bunch of font-related things as well. One of them is a tool called ttfdump or ttfdisasm. It's a TrueType font bytecode disassembler. So if you have a TrueType font with some bytecode programs in it, like hinting programs, for example, you can now dump those programs using this ttfdisasm tool. I guess I have to say which type of program I want to dump. Yeah, so let's dump the FPGM, and it gives you this like bytecode printout. Basically, you can see all the code that's in the font, and we don't yet have the code to execute the bytecode programs and actually do the hinting stuff, but this is sort of a first step towards adding support for bytecode hinting. So thank you very much, Benjamin, for making progress on that. And another thing that Benjamin also did, which was a huge improvement, was subpixel positioning for text painting. So we previously had this problem with vector fonts that we would snap glyphs or characters to integer coordinates when we would put them on the screen. And that meant that sometimes things would sort of shift horizontally or vertically in kind of unpleasant ways. And we came up with a system that Benjamin implemented where each pixel is now divided into 3 subpixels, and or actually 3 subpixels horizontally and 3 vertically, and then we choose sort of the most appropriate one depending on the floating point coordinate that you're trying to paint text at. And the end result of that is just that we can have much nicer looking text, which doesn't have nearly as bad kerning as we had before. So big shout outs to Benjamin for implementing that. Also, my voice is not fully recovered from COVID yet, so I apologize if it sort of dies out a little bit sometimes, or if I have to cough suddenly. Anyway, let's see. What's some other stuff? Oh, by the way, speaking of fonts, something I also did, which is such a simple thing, but I just love it, is you can now change the terminal font size very easily with Control Plus and Control Minus. Something that we should have had forever, but we didn't, but now we do. So that is very satisfying to do. When I implemented it, I just sat here doing this over and over. Let's see. So in ICC Profiles here, actually, that brings me to something else. So Nico has been working very hard on ICC color profile support. So basically implementing all this parsing code for color profiles, and also we have a tool for printing them out. And I showed it in the last monthly update video, but back then it was pretty bare bones. And now it can actually dump out a whole lot more information from these color profiles. So this is pretty awesome. It's definitely, I would say, like, this definitely feels like more advanced stuff. So I'm really happy that we're sort of dipping our toes into this type of thing. And I'm looking forward to seeing what Nico is going to do with this color profile data. I know that I think he also added code for accessing the embedded color profiles in PNG and JPEG images, although I don't know exactly how to test that. But yeah, as you can see here, like, we are understanding more and more of color profiles, and maybe one day we can even, I guess the end goal of this is to be able to use different color profiles and maybe use Serenity on a wide gamut color display or whatever it's called. I don't know. I'm definitely not an expert on this stuff, but I'm looking forward to learning more about it as this improves. And, oh, by the way, when we are resizing a window like this, and maybe more noticeably, a window like this that doesn't go in these chunky increments, this is now a lot faster thanks to window resizing optimization that Jelle did. So previously, the way resizing worked was that every time that you resized the window, we would deallocate the old backing store for the window and allocate a new one, even if you just resized it 1 pixel larger. And that created a huge amount of memory churn. We were just throwing away memory, allocating new memory over and over and over. And profiling this would show you that, like, most of the time was just spent freeing and allocating memory. And what Jelle did was that now when we're resizing, we actually add sort of a fudge factor or margin to the size, so that when you're growing the window in increments of, like, I think 64 pixels or something like that. I don't remember the exact number. But that basically avoids a whole bunch of resize steps and makes it way, way smoother. Also, I think when you shrink the window, you don't need to reallocate at all. You can just use the old allocation. So I think that's what we do there. But all in all, the end result is that resizing feels so much smoother, especially if you're running on a slower machine. So thank you very much, Jelle, for working on that. That is really, really awesome. Okay, so speaking of performance, let's look at something else. In the Assistant application, which is our sort of Spotlight-like, Tim Ledbetter has worked on a bunch of optimizations. So we now have much better query performance thanks to some caching improvements. And now type as you search as you type, or whatever it is called, it's now like super duper fast. It's like instantly responsive here, and it feels really good because there's no lag, there's no delay. It just finds the thing I'm looking for. And big shout outs to Tim Ledbetter for working on that. And let me open Solitaire here to show you something else. In card games now, I don't know, I need to actually have something that I can move around. Yeah, here. So Tim Flynn added this thing called highlights, I think, where when I'm hovering the 10 over the jack here, you can see that the jack card sort of gets this pinkish highlight frame around it that just indicates that you can drop this card here. So this is a highlights mechanism in libcards. So it should be available in all card games, although I guess it needs to be you need to write some code to take advantage of it, but it's the thing now. So thank you, Tim, for adding that. It's amusing to me that we have some people who just it's kind of obvious that they're just playing a lot of the card games, and then then they keep improving the card games because they play them so much, and you just love to see it. Dog fooding is a beautiful thing, and speaking of that, by the way, I think Sam also plays a lot of Solitaire or card games in the system, and I know he added a bunch of these dialogues where if you do something that might throw away a game in progress, then we always ask you now, are you sure that you want to quit this game that you have going on? So thank you, Sam, for doing that, even if it was for selfish reasons. Okay, so something else in Clipboard History. I know that we now have a way to clear the history somehow, although I'm not sure. Oh yeah, here. Okay, so this is how you get to it. You just right click and there's a clear history thing. So you can clear the clipboard history. Pretty neat. Previously it was just permanent. There was no way to get rid of it if you wanted to. So I think this was implemented by Tim Ledbetter as well. Oh, we can delete an individual thing. Interesting. Yeah, so thank you very much, Tim, for improving clipboard history. It's kind of I don't know, I almost forgot that we had this clipboard history applet, but it is a really useful thing. This actually makes me wonder if we should, or if we could make it have like a pop-up menu as well, so that you don't need to get this window, but you could like have quick access to maybe like the 10 most recent clippings or whatever. I don't know. Anyway, let me not get distracted with that because I'm in the middle of recording a video. Okay, let's go to Pixel Paint. So we have a couple of new things this month. One of them is the Gradient tool that was implemented by Torsten, I think. Pretty sure it was Torsten, yeah. And this is what it looks like. So I'm not super proficient at using it, but yeah, you can switch the colors. I don't know how to switch the secondary color. There might be some way to do that, but I don't actually know how to do it. There's only opacity. Anyway, thank you, Torsten, for adding this. And I think Benjamin as well for doing some improvements to it for better clipping and stuff. Benjamin, by the way, did some really awesome stuff this month. Speaking of gradients, I know that we had a lot of gradient painting code in LibWeb, which just came about that way because we needed to paint all these different gradients for web pages, for CSS gradients. But the gradient painting code is generally useful, especially since we have an application like Pixel Paint. But also, you know, there are scenarios when you want to draw gradients. And this month, Benjamin did a bunch of work to move gradient painting code and generalize it, move it into our common graphics library, LibGfx. So shoutouts to Benjamin for doing that. Okay. So another thing, I think Tim Ledbetter as well. Tim has been doing a bunch of stuff. Did crop to content. So the original crop to content, it just crops away all the transparent pixels. But now, if you have an image with a colored background, it will still work. Crop to content, because previously it would just look for transparent things and crop all that out. But now it identifies the background color of the image by sort of looking for if the entire bottom line is the same color, then it's considered a background color. So we remove that line, and then we keep going like that from every edge of the image, basically. And yeah, that's, I mean, obviously much, much nicer. So thank you, Tim, for implementing that. And then I think in the last monthly video, I complained about selections, like these types of selections being hard to see if you were drawing in a dark image. So, excuse me, if we had like, wait, I want to spray. Why can't I spray? Okay, now, wait, it's updating here. Or is it? No, it's not. I don't know what I'm doing wrong, but I can't do anything anymore. That is strange. Okay, it seems like we have some kind of bug here. Very strange. Okay, so let me make a new image. Okay, wow, beautiful, truly. So we previously had this issue that like the lasso select and the polygonal select, you couldn't really see them because they were rendered in just a black pen. And Tim this month went and made it, I think the solution was he just made it multicolored, so it's black and white, the outline while you're drawing it. So if you're drawing on a dark background, you see the white. If you're drawing on a light background, you see the black. And it's a simple solution, but it just works beautifully. So thank you, Tim, for doing that. All right, so I wonder what that bug was where I couldn't draw there. Anyway, some other random stuff. So we now have a sed program. Somehow, despite being a Unix-like system, we avoided having sed forever. And this month, Eli went and built a basic sed program. So you can now do stuff like, well, let's change root to something else. Root to cucumber. And look at that. Pretty neat. And I know the first cut of sed is pretty bare bones, and I think there are more improvements to it coming soon. But yeah, that's awesome to have sed. Definitely have to have sed. So thank you, Eli, for doing that, adding that. Another random little thing I saw was LS now has a so we previously had human readable sizes, but we now also have -SI, which are supposed to be base 10, I guess. Although, oh, it's, you can't use -H and SI at the same time. Yeah, so if you use SI, then you get base 10 instead of, what are the other ones called even? I don't even know what the other ones would be called. But yeah, so like a kilobyte is 1,000 bytes instead of 1,024. Would you call it base 2 maybe? So it's an interesting thing. I think it's part of POSIX. So we tend to do many things that are in POSIX. This was implemented by Arda. So thank you, Arda, for doing that. Sometimes I wonder if I should get used to these like base 10 type byte counts. I don't know. Do people use those? I'm kind of old school with this. Like I like the 1024 based kilobytes. Anyway, another thing that I don't know how to demonstrate, but I know that Nico fixed our UTF-16 codec this month because it was very naively implemented. And now we can actually decode UTF-16 that has surrogate pairs, which previously we would just mess that up. So big thanks to Nico for fixing that. And I guess that's basically everything that I had to show you here today. I was out myself this month for almost 3 weeks because I got sick. So it's really, really fun to just go through all this stuff that other people worked on. Anyways, now we are going to hear from Linus, who's going to talk about the browser stack.
So, after not being able to record for the last 2 videos, I'm back with some pretty exciting JS engine and browser updates. Let's start with the JavaScript ones. So we have 2 pretty big changes this month. One of them being that we started to add awareness to the engine, basically. So when you run out of memory somewhere, our goal is to handle that gracefully, ideally not crash the engine, and possibly even give you back an error that you can catch from JavaScript. And one big example of that is our string class, which you might have seen is being replaced now all across the system. The old one is now a deprecated string and needs to be phased out with a new string that knows about memory being a limited resource. And so Tim went ahead and started doing this conversion in LibJS. So let's have a look at some example. Right, for example here, in the string prototype, so when you say string literal dot blah blah blah, most of these are now aware that string allocation can fail. And so for the, in this example, we make a string that is 10,000 characters long. And then in an infinite loop, we just append that string to itself and print out the length. And so at some point, this will obviously fail because we run out of memory. So let's see how that looks. So if we do JS string and run that, you can see it slows down after a while as it takes more time to add these strings together. And the string keeps growing, and the memory use down here also keeps growing. And then at the very end, we have an internal error out of memory. And the program still exited gracefully. That we should be able to see. Oh, yeah, well, it returned 1, but that's fine. Because it exited with an uncaught exception. But since that's a regular JavaScript exception, we can just catch that and then do something. For example, like this. So same example, except now that loop is wrapped in a try-catch block. And we just check if the error is an internal error and then do something. For example, here we could do cleanup, or we do an alternative code path that doesn't need that much resources, for example. So let's run that as well. JS string catch. Same example, just keeps making a bigger and bigger string, and memory usage keeps growing, as we can also see here. And then at some point it should, yes, exit, say and this time it should not even have exited with 1, and indeed, because we catch the exception, it returned normally. Yes, so that's an ongoing effort. So Tim did a bunch of internal stuff and the string prototype and Intel, and I already started doing the same for temporal, and now we just have to go through basically the entire runtime and make everything use these new strings. But it's very exciting to see. And it will also tie in with Yacht, which has this concept built in. All right, let's see what's next. We have a new proposal implemented. So after the last TC39 meeting, the explicit resource management proposal got stage 3, at least a part of it. And then David went and implemented that in LibJS. And let's look at some examples there. So the basic form is that they introduce a new type of declaration, which is called a using declaration. It's very similar to const. So you could say const foo equals but now you say using foo equals. It can only be used in the block, so this is not valid in a top-level context. And this using declaration is pretty similar to a C++ RAII type, for example. So once the scope exits, it magically invokes the symbol.dispose function, if any is present. And then you can clean up some stuff there, or you just use it for logging, or whatever you might want to do. And so in this basic example, we make an object. In the constructor, we log something, and in the dispose function, we also log something. And we invoke this twice, once using a plain old const foo, and once using a using declaration. And let's see how that looks. JS, and that is using. As you can see, we log twice, creating resource for foo object. Now we're not actually doing anything, but just an example. And then once we log cleaning up the resource, which is from the dispose method. So yeah, this is brand new, still very experimental. I'm not quite sure if they will do something that you can, for example, not invoke or not assign the foo object to a regular const method, because I could see this being a common programming error where you mismatch these two, and then one ends up invoking the dispose method and the other doesn't. But we'll see. And this also involves a couple of other things. So for example, how it ties in with exceptions. So here we make two custom errors, one called outer error, one inner error. We have a boolean, dispose equals false. And then we have a try-catch block. And in that try-catch block, we say using a equals and then an object that has a dispose method. So once that block is exited, this dispose method will be called. Now, before we exit the block, we throw an error, which will obviously cause us to catch that and enter this block. But also, since we have a dispose method here, we need to call that somehow before here. And within that method, we throw another error. And this is an interesting case, because now which error should show up here? Because, it's not really clear which one comes first. And they handle that by introducing a new error type. So let's just run this as an example. JS using error. So we dump out a bunch of state here in the catch block. So first of all, we see that dispose got set to true. So this definitely got called, despite being an error here. And then the error object that we caught is now a suppressed error. So neither of these. It's a built-in one, which itself has an error property, which is the inner error, so this one, and a suppressed property, so the outer error, this one. And so we can see this one got thrown first, then it exited the scope, invoked the dispose method through another error, and so the suppressed error is now the one that got thrown first. And the other one is still captured on the object, but in the end you get access to both of them. So they took care of that as well. And then lastly, I think there's a third example here. They added a new built-in object called the disposable stack, which you don't need to use in a scope. So this can be in the global scope, but it uses very similar concepts. So what you can do is add a defer method, which you might know as a built-in statement from some languages. So for example, in Zik, the way you clean up allocations, I believe, is you allocate something and then just after that you say defer, deallocate. So you could do something similar here, or it allows you to sort of adopt some object, and then once the stack gets disposed, you can run a callback for that to do some cleanup. So they have a bunch of methods for that. And once you're done doing stuff, you just say disposable stack.dispose and it will run those for you. So let's try that. And indeed, we went all the way from line 1 to line 16, where it says disposing stack. We printed that, and then it just ran through everything that we registered. So one defer function, then the adopted object where we have a callback, and then a second defer, and then we reach the end. And you can also see that those are in reverse order, so the last one will run first. Yes, enough about that. Really great work from David. And the part that is missing is async disposable stuff, which didn't get approved in TC39, so they are still working on that. But maybe this month. And some smaller stuff. So Andreas has done a very interesting fix in the GC, which I want to mention. So too many text editors. So let's look at this example, which just makes an object and then assigns a next property, which is also an object, and then it assigns another next property to that, and so on. So this is a very deeply nested object graph with objects referring to other objects, and then we run a garbage collection. And previously that would crash the engine with a native Stack Overflow, so the C++ stack would just reach the end and the program would crash, just because we would recursively visit these objects and their members. But now this works slightly differently, so we just create a list basically of things that we need to visit and then loop through them until we don't exhaust the stack space, which is definitely quite helpful. And then what else? Tim did a bunch of updates to number format version 3, which has reached stage 4 just today in TC39, so that will be in the main spec soon. And I did a small fix on lazy object creation. So we have the global object, obviously, global this, which has a bunch of stuff on it, which just takes time to initialize. So what we now do, or what we already did, is we lazily initialize a bunch of these objects. So for example, any of these, they will exist, but you can even see here it's empty, and they will only get created once you first access them. But we missed an opportunity to also do this for a bunch of namespace objects like math or temporal. So these are now lazily initialized as well, so we don't actually have to create all of this before you use it, which is nice. That's it for JavaScript. All right, let's look at the browser and LibWeb changes next. First of all, we have a bunch of work on CSS Pixels from Sam, who has been doing this for a while now. And CSS Pixels are this concept where one pixel in the CSS definition might not necessarily match one pixel on the rendered output or on the screen. So for example, if you say your border is 1 pixel wide, in the CSS, it might render as 2 pixels on the screen if it's a high resolution screen, for example. And not having that made websites look very tiny on such screens, which should now be rectified. So we, at least on the Ladybird build, we just take the display scale and then tell the browser how it should scale accordingly. And speaking of scaling, we can also use that for zoom in and zoom out actions, which I've added to the browser and Ladybird this month. So for example, in View, zoom in, zoom out, and reset, usual shortcuts. So I can do this, and you can see the background zooms accordingly, the bullet points do. The text doesn't yet. This needs fixing, but it's almost there. And zooming out works as well. So thanks, Sam, for this ongoing work. It's really nice to see how far it's come. Next up, we have some improvements to gradients. Well, not improvements, a new feature basically, because you now can use them in canvases as well. So we used to have it for CSS backgrounds since a while ago. MacView has added those. and now they have made their way into canvases as well. So these are canvas elements here. Down here we have some interactive demos, so we can do mouse over effects. It freaks out a little bit if I do this. Not sure if that's intentional. Conic gradients work as well, and you can even clip them along a path. So that's really nice to see that our rendering abilities are improving here. And MacDue has also moved a bunch of the gradient painting code to LibGfx, which is the graphics library used across the system. So this is now also possible to use outside of the browser very easily. It's always nice to generalize stuff where possible. And then we have a bunch of improvements to table layout and rendering, which is nice because table support was present since quite a while ago, but hasn't really improved that much since then. And now you can see here different variants with a border around it or no border, different border spacing, all that. And this was done by Alexander and Martin, who worked on this. Alexander also worked on a bunch of other layout stuff, which was great to see. And then Martin continued work on CSS Grid, which now gained the ability to use template areas, which I can show you here. So we define, for example, in this example, where it says should be taking up 1/3 of the grid. Where is it? Yes, this one. So we have a grid container where we say the style is template columns A, B, and C, each 1/3, and then the areas are A, B, and C. So this is the order in which they appear. And then we have one child element which just specifies it starts at area A or column A and ends at column A. So this ends up as 1/3 of the full width. And this is a nice way to specify layouts like that, because it's very easy to understand, I think. So great to see the continued improvements of CSS Grid here from Martin. Next up, we have some work on a rather basic feature, which is HTML forms. So made a basic example here, where we just have one text input, one with a default value, and then a button with type equals reset. So the type is by default submit, so it would submit the form. It can also be button, which then just invokes some JavaScript. But here we have reset, which is a built-in type. And as you might guess, if we change something here, it resets the form to its default state. So empty here or preserving the default value in the other case. And this was added by Skrikovin, so thank you for that. It's really nice to see that we support more of the basic HTML features as well, and don't need JavaScript for this. Okay. Next up, we have a new feature in the browser, which is backed by a new feature in LibWeb, so it's sort of twofold. Let's look at the inspector. So on the DOM inspector, we have a new tab called accessibility. And instead of seeing the DOM tree like you would here, where we show you the internal tree created from the HTML, we now have an accessibility tree as well, which is sort of a simplified version of this, where you can see it starts with a document, and then it has nodes like a paragraph, generic, or let's actually try this on this page, which might be easier to understand. So, right, we have document, which has the title welcome up here, and then it has a heading, which says welcome to the Serenity browser, and below that a paragraph with some text and another one, and then it has a navigation with another heading here, and a list, which has a list item, which itself has a link, and so on. So you can see how this works. And this is the basic idea of how a screen reader would interpret this page. So it would not try to parse the HTML itself. it just looks at this accessibility tree and then allows navigating the website that way or reading content. And this is also, there's attributes where you can specify what a certain element is. For example, if it's just presentational, or you can say it's hidden in the accessibility tree, things like that. And this work was done by Jonah, so thank you for that, both for the internal implementation and the browser feature here. And then lastly, I want to mention another thing, which I basically mentioned in LibJS earlier, which is the lazy initialization of objects. So the various web APIs that we have, which are built in, basically now lazy initialize as well. So not just the LibJS JavaScript features, but the web APIs as well. And that was done by Tim. So another oversight basically where we had that capability but didn't really use it. I think that's everything. So back to Andreas.
All right, and that's everything that we had to show you here today. Thank you all so much for checking in and staying up to date with the SerenityOS project. If you want to come chat, we have the Discord server. There's a link to that in the video description. And I also have a live stream here on YouTube. It's Fridays at 4 p.m. Swedish time. Come say hi. If you want to sponsor development of SerenityOS, there are a bunch of us developers who have sponsoring options. You'll find links to that in the video description as well. But now this is it for this month. So thank you very much for stopping by, and I will see you all next time. Bye.